Good evening. So exercise 2.3, sum number 6. Okay. Now the function, do not write the solution because I will upload this. Just listen to me. The function f of x equal to x into x plus 3 into e raised to minus x upon 2 satisfies all the conditions of Rolle's theorem on closed interval minus 3 0. Find the value of c such that f dash of c is nothing but 0. This is not difficult, but because of three terms, actually we will reduce this to two, because if you open the bracket, this is just a polynomial and this is exponential. So fx is x into x plus 3 into e raised to minus x by 2. That is x square plus 3x into e raised to minus x by 2. What is f dash of x? First function x square plus 3x into derivative of second plus second function into derivative of first. Now tell me, what is derivative of e raised to minus x by 2? It is e raised to minus x by 2 into derivative of minus x by 2, which is minus half. Okay, plus second function into derivative of first. What is derivative of x square plus 3x? It is 2x plus 3. Okay, so the next step, so this is the next step, right? Take e raised to minus x by 2 common. So in bracket, you get what? 2x plus 3 minus x square plus 3x upon 2. If you find LCM and then simplify, you get f dash of x equal to what? E raised to minus x upon 2 into, what are the factors of 6 plus x minus x square? They are 3 minus x into 2 plus x. So f dash of c will be what? Replace x by c. That's it. Now f dash of c equal to 0 gives e raised to minus c upon 2 into 3 minus c into 2 plus c equal to 0. But note that e raised to minus cannot be 0. So this gives us 3 minus c equal to 0 or 2 plus c equal to 0. That gives me c equal to 3 or c equal to minus 2. But note that 3 does not belong to the open interval minus 3 0, but minus 2 belongs to this. And therefore, what is the value of c? C is nothing but minus 2. In fact, I'll explain this once again. The function satisfies all the conditions of Rolle's theorem on closed interval minus 3 0. Find the value of c belonging to open interval such that f dash of c equal to 0. So what is important in this case? The most important thing is to find the derivative, and you have to use the find the derivative using which rule? You have to use product rule for that. Okay, so on simplification, you get f dash of x as what? E raised to minus x by 2 upon 2 into 3 minus x into 2 plus x. So what will be f dash of c? Simple, replace x by c. So if you equate f dash of c with 0, you get this. Now this cannot be 0. So either 3 minus c is 0 or 2 plus c is 0. That gives me c equal to 3 or c equal to minus 2. But 3 does not belong to this open interval, but minus 2 does belong. So we conclude that c equal to minus 2. Okay, so this is the answer. Write down f of x equal to log x. Now you have to write this logarithm function is continuous. Logarithmic function is continuous on r plus. What do you mean by r plus? R plus means positive real numbers. Is continuous on r plus, and hence continuous on closed interval 1 comma e. How to write this? Closed interval 1 comma e, see on the screen, and is differentiable on open interval 1 comma e, open interval 1 comma e. Thus the function f satisfies the conditions of Lagrange's mean value theorem. Conditions of Lagrange's mean value theorem. Therefore, there exists small c स्क्रीनवर बघा, belonging to open interval 1e, such that, what is the requirement? Such that f dash of c is f of e minus f of 1 upon e minus 1. Now, what is f of x? F of x is log x. So, what will be f of 1? It will be log 1. What is log 1? Log 1 is nothing but 0. And what is f of e? It is log e. We are doing calculus, so base of logarithm is e only. So log of any number to the same base is 1. Okay. Similarly, what is f dash of x? Derivative of log x is nothing but 1 upon x. Therefore, f dash of c is nothing but 1 upon c. I can give number 1 to this. So after that, I will write, therefore, from 1, tell me what you get. 1 upon c is nothing but 1 minus 0 divided by e minus 1. So tell me, what is the value of c? Therefore, c is nothing but e minus 1. Now tell me whether e minus 1 belongs to that interval or not. Approximate value of e is what? 2.718 less 1 is 1.718. Yes, this definitely belongs to open interval 1e. Hence, LMVT is verified. Therefore, I can say LMVT is verified. Right on. Now the second one, f of x is what? X minus 1 into x minus 2 into x minus 3. Obtain this as a polynomial. Tell me what you get. I write this as, I take product of first two. So x square minus 3x plus 2 into x minus 3. Now you have to tell me, open the bracket. I will not write. First you tell me what is your answer. Now clearly it is a polynomial function. Find out. Check f of x. It should be x cube minus 6x square plus 11x minus 6. Okay, this is a polynomial function and is continuous on closed interval continuous on closed interval 0, 4 and differentiable, write down, on open interval 0, 4. Therefore, LMVT conditions are met, satisfied. Okay, so LMVT conditions are satisfied. Therefore, there exists, see, this is not at all difficult. If you know the theorems, you can easily find the answer. There exists small c belonging to open interval 0, 4, okay, such that f dash of c is what? F of 4 minus f of 0 upon 4 minus 0 dot 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 number 1. Now find out all these values, substitute. What is f of 0? Replace every x by 0. So I will directly write minus 6. So f of 0 equal to what? It is equal to minus 6. What is f of 4? Find out. Don't write directly. It is nothing but, or you can put that here, so you get answer easily. X minus 1. So 4 minus 1, why to put that in expansion? Then into 4 minus 2 into what? 4 minus 3, because that x cube wala part is the expansion of this only. Okay, so you will notice that this comes out to be 6. Find out f dash of x. Find out f dash of x. So f dash of x is nothing but 3x square minus 12x plus 11. Differentiation is not at all difficult. Let me show you the function. See, this is the function. What is derivative of x cube? 3x square. Here minus 12x plus 11. Derivative of any constant is 0 only. Okay. So this is nothing but f dash of x. Therefore, from 1, tell me what you get. So from 1, f dash of c will be what? It is better to write that separately, but here I will write directly 3c square minus 12c plus 11 is nothing but, what is f of 4? It is 6 minus 6 upon 4 minus 0. Now solve this equation. Solve this equation for c. So in the next step, 3c square minus 12c plus 11 is nothing but 12 upon 4, that is 3. Therefore, 3c square minus 12c plus 8, nothing but 0. Now, can you find the factors of this? No, factors cannot be obtained. So you have to use formula. So what is difficult? Finding the value of c by using formula of roots of quadratic equation. So tell me what is c? It is plus minus, in fact minus b. So minus of minus 12, that is 12, plus minus root of b square. I will directly substitute So 144 minus 4ac. What is a? 3. And what is c? C is nothing but constant term. Okay. Divided by 2a. So 2 into coefficient of c square, which is 3. Now you will tell me the answer. I will not tell you the answer. Find out. ओके ओके, ठीक आहे ठीक आहे. रमा ठीक आहे, मग हरकत नाही. अशा वेळेला काय टाईप करावं माहितीये? 2 PLUS MINUS 2 UPON किंवा 2/ROOT3, कारण रूट तसं येणारच नाही ना, तुम्हाला टाईप करताय. ठीक आहे, ओके. बघा हे महत्वाचं सम होतं. झालं असेल तर थांबायचं नाही. पुढचं सम जस्ट एकच मिनिट, मला सम काय ते बघू दे. ठीक आहे, ज्यांचं झालंय त्यांनी थांबू नका. थोडं मी डिक्टेट करणार आहे, कारण बघा प्रेझेंटेशनला महत्व दिलंच पाहिजे. जसं अनेक लोक बघा मोबाईलवर ठीक आहे, पण ते ओके टाईप न करता नुसतं के लिहितात. म्हणजे मिली सेकंड वाचून तेवढ्या वेळाचं काय करतात हा एक प्रश्न आहे. तसं इथे तुम्ही अर्धवट लिहून उरलेल्या वेळात नेमकं काय असं चांगलं काम करता की जे जस्टिफाय होईल यांनी, की नाही नाही आम्ही अर्धवट किंवा नुसती कॅल्क्युलेशन्स. प्लीज डोंट डू दॅट. ठीक आहे, चलो पुढचं मी थोडं डिक्टेट करणार आहे. काय फंक्शन आहे चेक करा. राईट डाऊन. f of x equal to x minus 1 upon x minus 3. F of x equal to x minus 1 upon x minus 3 is a rational function. Is a rational function and is continuous except at x equal to 3. Why? Because if denominator vanishes, function is not defined. Except at x equal to 3. But 3 does not belong. स्क्रीनवर बघा कसं लिहायचं. But 3 does not belong to closed interval 4, 5. 3 does not belong to closed interval 4, 5. Therefore, it is continuous. I mean that function. Therefore, it is continuous on closed interval 4, 5 and differentiable on open interval 4, 5. Open interval 4, 5. Thus, f satisfies conditions of LMVT. Thus, f satisfies the conditions of LMVT. Therefore, there exists C belonging to open interval 4, 5. स्क्रीनवर बघा हवं तर. C belonging to open interval 4, 5 such that f dash of C equal to f of 5 minus f of 4 upon 5 minus 4 dot number 1. Okay, Now find out derivative. Now I can use shortcut method to find the derivative. See how I'm finding the derivative. What is f of x? What is f of x? It is x minus 1 upon x minus 3. Let me explain. One method is just go for differentiation using quotient rule, or can I say x minus 1 is x minus 3 plus 2 upon x minus 3. Yes, I have written the same in required form. Okay, so f of x is nothing but if you split numerator, then 1 plus 2 upon x minus 3. Okay, now I will find values of the function as well as f dash of x from this. Okay, so what is f of 4? Tell me what is f of 4? It is 1 plus 2 upon 1. 2 upon 1, that is nothing but 3. What is f of 5? F of 5 is 1 plus 2 upon 5 minus 3, that is 2. So it is 1 plus 1, that is 2. And the most importantly, what is f dash of x? See how f dash of x can be obtained easily. Derivative of 1 is 0. 2 into. What is derivative of 1 upon x minus 3? It is minus 1 upon x minus 3 bracket square. So if you simplify this, you get minus 2 upon x minus 3 bracket square. Is that clear? Now substitute. Therefore, from 1, I will write f dash of c directly. Minus 2 upon c minus 3 bracket square equal to, substitute the values. So that gives me 2 minus 3 upon 1. Is it correct? Yes. Because f of 5 is 2 minus f of 4 3 upon 5 minus 4, that is 1. So this is nothing but minus 1. So if you rearrange the terms, tell me what you get. So I can directly write c minus 3 bracket square equal to 2. So c minus 3 is plus minus root 2. Plus minus root 2. Therefore, c equal to 3 plus minus root 2. What is the approximate value of root 2? 1.4 if we consider. Then 3 plus 1.4 is what? 4 point, and 3 minus 1.4. Does it belong to the interval 4, 5? No, it does not. And therefore, I have to write as c equal to 3 minus root 2 does not belong to open interval 4, 5. C cannot be 3 minus root 2. What about 3 plus root 2? It is 4 point something. So lies between 4 and 5. But C equal to 3 plus root 2. It belongs to open interval 4, 5. Therefore, LMVT is verified. Right. Okay. Now we discuss the concept of increasing and decreasing function. Consider the graph of the function f. let P be the point x equal to a on this graph. What will be the coordinates of P? X coordinate is a. So what will be the y coordinate? It will be f of a. Okay. We observe that while passing through this point from left to right, the graph of the function is rising. That is, the values of the function are increasing. In this case, we say that f is an increasing function at P, that is at x equal to a. Now the next concept is interesting. See, graph of the function can be like this also. So instead of considering the complete domain, what we do is, see, this is x equal to a. We consider a very small neighborhood of a. Neighborhood means what? Very small numbers to the left of a and to the right of a. For that, we consider delta as a positive number, so that a minus delta will lie to the left of a and a plus delta will lie to the right of a. Now, first listen, if you have any difficulty, I'll explain again. Now consider a small neighborhood, that is open interval a minus delta a plus delta of a. See, this interval is given the name neighborhood of a. Okay. Now we consider any 2 points x1 and x2 in this neighborhood such that x1 is less than x2. Suppose I consider these points. This is say x1 and this is say x2. Okay. This is x1 and this is x2. What is requirement here? X1 is less than x2. Now tell me, what about f of x1 and f of x2? See, f of x is value of the function. For that, you have to consider projection on y-axis. So you will notice that f of x2 is greater than f of x1. In other words, f of x1 is less than f of x2. Okay, and therefore we can say a function f is said to be increasing at x equal to a if there exists some neighborhood open interval a minus delta a plus delta of a such that for any 2 points x1 x2 in this neighborhood with x1 less than x2, we have f of x1 less than f of x2. I will repeat this. So how to define an increasing function? A function f is said to be increasing at x equal to a if there exists some neighborhood open interval a minus delta a plus delta of a such that for any 2 points x1 comma x2 in this neighborhood with x1 less than x2, we have f of x1 less than or equal to f of x2. F is said to be strictly or monotonically increasing at x equal to a if for any 2 points x1 comma x2 in this neighborhood with x1 less than x2, we have f of x1 less than f of x2. If you draw tangent at the point at which function is increasing, you will notice that the tangent makes an acute angle with positive direction of x-axis. So slope of the tangent, which is tan theta, is positive. But tell me, what is the slope of tangent? F dash of a represents the slope of tangent to the curve at a point x equal to a on the curve, and therefore the conclusion is if the function is increasing at x equal to a, then f dash of a has to be greater than 0. We will be using this criterion. Okay, so this is about an increasing function. Similarly, we can discuss decreasing function. So what can you say about decreasing function? I consider open interval a minus delta, a plus delta of a. This is again the curve y equal to fx. This is the point P on the curve. Okay. So while passing through this point, you will notice that the graph of the function is decreasing, right? So in this case, I will say consider again same. Consider the function whose graph is shown here. Function f is decreasing at x equal to a while passing through the point A. So can I say that a function f is said to be decreasing at x equal to a if there exists some neighborhood a minus delta, a plus delta of a, such that for any 2 points x1, x2, I'm considering this as say x1 and this as x2. What is observation? X1 less than x2. But can you tell me about f of x1 and f of x2? You will notice that f of x1 is greater than f of x2. Okay. So in that case, we say that function is decreasing. Now here the function is strictly, that is monotonically decreasing, but in some cases, though x1 is less than x2, f of x1 can be equal to f of x2. So in that case, we do not say that the function is strictly decreasing. Now you will have curiosity about that. When does this happen? See, at these 2 points, you will notice that functional value is the same. Okay, so it happens at this point. So this point is called as stationary point. I hope you understood this. So again, I will define decreasing function. A function f is said to be decreasing at x equal to a if there exists some neighborhood a minus delta, a plus delta of a, such that for any 2 points x1 comma x2 in this neighborhood, such that x1 less than x2, we have f of x1 greater than or equal to f of x2. F is said to be strictly or monotonically decreasing at x equal to a if for any 2 points x1, x2 in this neighborhood with x1 less than x2, we have f of x1 only greater than f of x2. Now in this case also, if you draw tangent at the point at which function is decreasing, you will notice that the tangent drawn makes an obtuse angle. See, at this point, at P A f of a, the function is decreasing, right? Tangent is drawn at this point. What is the slope of this tangent? It is f dash of a. But tangent makes an obtuse angle. So tangent ratio of that angle, which is nothing but slope of the line, is negative. Obtuse means second quadrant. In second quadrant, tangent ratio is negative, and therefore f dash of a is less than 0. I hope you understood this. So you have to just remember what, that for an increasing function, f dash of a is greater than 0, and for a decreasing function, f dash of a is less than 0. There is one more case, f dash of a equal to 0. So in that case, you will notice that the function is neither increasing nor decreasing. Okay, because if you draw tangent, it is parallel to x-axis. The title is increasing and decreasing functions. In that, write down, let a function f be differentiable. Let a function f be differentiable at the point pxy. At the point pxy. Then, number one, f is increasing at p, f is increasing at p if f dash of x greater than or equal to 0. F is increasing at p if f dash of x greater than or equal to 0. Second, number 2, f is decreasing at p, f is decreasing at p if f dash of x less than or equal to 0. I repeat second part. Second, f is decreasing at p if f dash of x is less than or equal to 0. Number 3, f is strictly increasing. F is strictly increasing at p, if f dash of x greater than 0. Number 4, f is strictly decreasing at p, f is strictly decreasing at p if f dash of x less than 0. सम्स करताना अजून चांगलं. ओके, नाउ एक्सरसाइज 2.4 फर्स्ट मतलब फर्स्ट पार्ट. What is f of x? X cube minus 6x square plus 12x minus 16, where x is real number. So tell me what is f dash of x? F dash of x is nothing but 3x square minus 12x plus 12. Do you agree with me? Now I can take 3 common. Let me explain, then only you will write. So x square minus 4x plus 4. So this I can write as x minus 2 bracket square, 3 into x minus 2 bracket square. Now next part is important. So I can say this is greater than or equal to 0. Let me explain. For all x belonging to capital R. मी असं का म्हटलं रे? सी x is real, so x minus 2 is real. Square of any real number is either 0 or positive. Multiplied by 3, same thing. So 3 into x minus 2 bracket square is either greater than or equal to 0. How to read this? You have to read this as for all, for every. So for all x belonging to R. And therefore I will say that the function is increasing for all small x belonging to capital R. Now write down. So this is the final answer. हा जो सिंबल आहे ना तो उल्टा ए आहे बरं, इन्व्हर्टेड ए. असं वेगळं काही याला नाव नाहीये. यू हॅव टू रीड दिस एज फॉर ऑल, फॉर एव्हरी. ठीक आहे. बर, हे झालं असेल तर तिसरं करायचं. I'm sorry. Second, there are only 2. Let me check once again. Which is the second one? X minus 1 upon x. Okay. This is interesting. Now x belongs to R. X not equal to 0 because if denominator vanishes, it is absurd. Okay. So what is f dash of x from this? You should be able to write this directly. Derivative of x is 1. What is derivative of minus 1 upon x? It is plus 1 upon x square. Now I will say this is definitely only greater than 0. Don't say equal to 0. This can never be equal to 0 because 1 upon x square is 110% positive. So we are not interested whether it is greater than 1 or 2 or 3, whether it is positive or negative. The answer is it is positive. Okay. Therefore, after this I will say for all x belonging to R, x not equal to 0. So what is the conclusion? The conclusion is f is increasing. F is increasing. F is increasing for all x belonging to R, x not equal to 0. Okay, just a minute. X cube minus 6x squared. Okay, there is a correction in the next sum. See, in the second sum, what is the function? It is x cube minus 6x square plus 36x plus 7. Make the change. It is actually x cube minus 6x square minus 36x plus 7. Please make this change. X cube minus 6x square plus 36x, I'm sorry, minus 36x plus 7. Okay. Right now. Second question, find the values of x for which the following function is strictly increasing. Strictly increasing means first derivative should be just greater than 0. Okay. So write the function, find the derivative. What is f of x? It is given to be x cube minus 6x square minus 36x plus 7. Tell me what is f dash of x. You should be able to write derivative directly. It is 3x square minus 12x minus 36. Is that clear? Now f is strictly increasing. Write down. F is strictly increasing if f dash of x is greater than 0. See, that is why I have explained how to solve inequality. So what is difficult? Derivatives? No, solving an inequation. So that is important. That is 3x square minus 12x minus 36 greater than 0. That is what? X square minus 4x minus 12 greater than 0. Now there are two methods. I will explain the simple method. I will explain the second also, but it is better to use first method. See, observe x square minus 4x. This can be perfect square of x minus 2. Tell me what is x minus 2 square? It is x square present minus 4x present plus 4. We have unnecessarily added 4. So I will subtract 4. I will explain this once again. I have underlined terms in x. So for these two terms I am writing x minus 2 square. Why x minus 2 only? Because coefficient of x is minus 4 you have to divide it by 2. We have done this in integration also. So if you square, you get what? X square present minus 4x present plus 4. We have unnecessarily added 4, so we subtract 4. But minus 12 right from the beginning is there, so we have to consider that also. So effectively what? X minus 2 bracket square greater than 16. Now you should know how to solve the inequation x square greater than a square. For that I will write this: x square greater than a square gives, you should know this, x less than minus a or x is greater than a. So in this case, tell me what will be the solution? The solution will be x minus 2 less than minus 4 or x minus 2 greater than 4. That is, x is less than minus 4 plus 2 is minus 2 or x is greater than 6. So for these values, the function is definitely increasing. See, I will explain how to solve inequation once again, but let me write the final answer. So I can say f is strictly increasing. F is strictly increasing if x is less than minus 2 or x is greater than 6. In fact, I can write this using interval notation, that is open interval minus infinity minus 2 union open interval 6 infinity. Do you agree with me? x less than minus 2 म्हणजे किती लहान? up to minus infinity पर्यंत. x 6 or greater than 6, not 6, I'm sorry, strictly म्हटलंय greater than 6 up to plus infinity. So you can write answer with this notation also. So in case of strictly decreasing, you are required to solve which inequation? X square less than a square. And what is the solution? Minus a less than x less than a. So we stop here.